you've heard in the OpenShift 4.0 release update, wonderful thing that Clayton and Derek and Mike did a little bit about operators. If you don't know what an operator is, this next talk is going to get you up to speed and hopefully showcase some of the work that our wonderful partners have done, building operators and making their services available on OpenShift. And we're really thrilled that this new technology is part and parcel of the OpenShift ecosystem now, and that looks like most of you are coming in. So I'm going to stop talking and introduce one of my favorite PMs, Rob Szumski, and let him talk a little bit about Kubernetes operators.
Thank you, Diane. Hi, everyone. So we covered some about operators and how we use them on the platform a little bit earlier this morning. I want to talk mostly about operators running applications. You got a little sneak peek of this at the very end with the AMQ Streams Kafka operator. But before we get into some of the specifics, I want to step back and talk about where operators come from. I joined Red Hat through the acquisition of CoreOS, where we originated the concept of operators in 2016. And so I want to take us through a little bit of history, a little level setting on operators and their basics, and then we'll talk about some applications and things like that. And so when you talk about operators, it really maps back to how we run applications on Kubernetes. And this roughly follows three main cycles. The first was we had our stateless apps. These were the scale-out Nginx front ends and caching tiers and things like that. That were very easy to run, used replica sets and deployments, and this was kind of the first wave of applications to run successfully on Kubernetes. And then very quickly after that, we got to stateful applications, and we had to make some changes to Kubernetes to actually make this happen. So this is where we get stateful sets and the container storage interface, moving pod volumes around as they get rescheduled from node to node. And this unlocked stateful services for the first time, so you could run a very simple Postgres database, other things that you had that used local state. And this was great. Now we had a second wave of applications coming onto Kubernetes, and everything was great. Then we got to the complicated part. This is running full distributed systems on top of Kubernetes. And we started to hit some boundaries just in terms of the objects that are in Kubernetes. We've been building off of these primitives that the community worked so hard to build. But there's no kube object for data rebalancing. There's no objects for backup and restore. We've got some primitives for auto scaling, but triggering those needs to hook into your application. Doing a seamless upgrade, we can do rolling updates of containers, but that means something in a complete distributed system. And so we have to think at a layer a little bit higher than Kubernetes. We can, of course, use all the great tools in Kubernetes to make this happen. And so what is that? What is the thing that makes that happen? It's an operator. And at its core, an operator is taking knowledge of how you run an application, the knowledge that an ops team has when they're following a run book or a wiki, or maybe you've got some failover scripts for taking a standby database and making it into a primary. All that expertise in running your application is embedded into an operator from those experts, and then you've got this immutable artifact that can be deployed on a cluster. We like containers because they're immutable, and we can just ship our code in them, and we know that if I start this container on a cluster, it's going to come up the exact same way. Now you have that for an operator, but it's a complete distributed system that operator represents. And so, of course, the operator at the end of the day needs to make all these kube objects that we just talked about. So it's going to stamp out stateful sets and deployments and make secrets and config maps and all of that. And using those kube primitives is really, really powerful for a few different reasons. The first is that you can now have extremely flexible application architectures like your developers are used to if they were stamping out raw VMs or whatever orchestration environment that they're used to. You can construct any of these applications. It doesn't have to be a 3-tiered app. It doesn't have to be a certain type of workload. It can be anything. And then you're using all these Kubernetes primitives, so you're not reinventing the wheel. Nobody here needs to reinvent secret storage, service discovery. All these things are handled by Kube for us, and so we can use that kind of toolkit that we have in the ecosystem that's always getting better and better to build these applications. And because you're using Kube, you're also getting a uniform debugging experience. If you've got an engineer on one team and an engineer from another team happens to be on call, if they want to get streaming logs out of a pod, they know exactly how to do it. If they need access to a certain namespace in a cluster, they know how to use role-based access control. All these things are really, really nice when you've got cross-pollination. You can have teams that are sharing different Jenkins or CI pipelines. Maybe they don't share 100% of it, but they share 95% of it, which is really, really powerful. And then the most powerful part of Kube is that it's hybrid. You can run this on any infrastructure, on a number of different Kube providers. This operator concept is not specific to OpenShift. We think we have a really great experience inside of OpenShift, of course. But it allows you to really address that hybrid market. Now, I think a lot of folks here are typically running infrastructure in-house, but if you are a software vendor and you actually need to ship software out to a bunch of customers, what better tools to have than Kube APIs and containers to actually get these consistent deploys? And so you can ship an operator to those customers and stand it up, the exact same in 1,000 different customer environments, no matter what infrastructure they're running, because you're targeting Kubernetes. So you just addressed basically the entire next generation of infrastructure all with one operator. So do we want that? Does that sound great? Is that the nirvana that we're used to? We're going to get there. So let's talk about how we get there. So we've got the operator framework. You heard this mentioned earlier. And this really is focused on two different groups of folks. And it roughly talks about what I just laid out, which is for people that are building software and shipping software in either commercial entities or open source communities, the operator framework helps you get started building an operator. So we've got a set of CLI commands and different technologies that you can use to instantiate those. So we're going to talk about those and dig into it in a little bit more detail. And it's a really nice way to have this standard set of tools for a bunch of different teams that are inside of your organization. And then for the application consumers, the folks that are actually running this software, now they have a really consistent way to deploy these applications, keep them up to date. We've talked about, as Clayton said in the very beginning, there's more and more security vulnerabilities. And this is just the life that we're going to live now, is constant updates to these CVEs coming out. Especially as you have more and more components inside of a complex distributed system. Kubernetes has had CVEs in its DNS server and other things like that. And your application is no different. There's always going to be these bugs. So you want to have a way to do application lifecycle. And the operator framework has a tool just to do that. And then these teams can consume these applications in a correct manner using all that operational expertise that's baked in from the experts at Mongo and Redis and Postgres, whatever you're running. Because they know how to do it, they know how to secure it, and so then you can just get this point-click, very self-service manner of deploying these applications. So the framework is made up of 3 different pieces of software, and they're all kind of targeted on that entire application lifecycle that I just talked about. So we've got our operator SDK to help you build operators. This is a bunch of code generation and scaffolding that helps you really quickly get started. And then you've got the operator lifecycle manager. This is a part that works on any Kube distribution. This is pre-installed by default on OpenShift 4. And this allows you to run a set of operators on a cluster and manage their lifecycle. So if you need an update, an operator from version 1 to version 2, and then that operator manages 1,000 database instances. But you might just not have one of those. You're going to have a bunch of namespaces and do access control, roll out different versions of the operator to different sections of the cluster first. Lifecycle Manager helps you with all that. And then lastly is operator metering. And this is the idea that you need to have operational metrics at scale when you're running these types of systems. So you've got a database operator that's running 1,000 instances of Postgres. You want to get operational statistics about how that operator is managing all of those clusters, how the specific clusters are doing, if there's any hotspots, and then be able to meter against any sort of dynamic metric that it keeps inside of its memory. So the operator SDK has hooks in so that you can expose custom metrics about your application and then meter and aggregate those. All this is housed in a vendor-neutral GitHub framework, operator-framework, and it houses all 3 of these main tools, as well as a bunch of docs and guides and testing infrastructure and that type of thing. Also really important to understand with an operator is the maturity model. And so this is kind of always evolving, and hopefully we'll get past phase 5, but we think about it in 5 main phases today. And phase 1 and 2 are basic install and upgrade. This is kind of table stakes at this point. To have that full application lifecycle, you need to get to phase 2, basically. And we're pushing all of our partners to get there. All of the OpenShift operators, go a little bit further past this. And ideally, we all get to phase 5 really quickly, which is the kind of picture the most perfect cloud service you've ever used, the experience that it does vertical and horizontal auto scaling. It might tune itself differently based on the number of requests that it is handling. It knows how to do hook into the Kubernetes scheduler to make sure it's picking just the best nodes for your application to run on. It's doing auto failover, auto remediation. Just picture, you never have to interact with this cloud service. We want to build all operators to fulfill that experience in a truly hybrid way. So you're not tied to a single cloud provider. You are using like a database operator, a machine learning operator to get that same experience, but on infrastructure that you own. On the bottom side of this, you'll see three little bars. These are the SDK flavors that we're going to talk about. And the idea here is that no matter what kind of expertise you have in software development, infrastructure, ops, that you have an SDK to build operators against that matches your skill set. So we're going to dig into all of these in detail. It is worth noting that the Helm SDK is mostly for like stateless and very simplistic stateful workloads. And so you can kind of get to install and upgrade, but you don't have a lot of that rich logic that you get in two of the other SDKs. And we'll cover that in detail. So here's the three SDKs, again, feeding into a common testing framework. And so this is really important because if you think about what you're doing when you're building an operator, there's this loop that's constantly running, just like all of the Kubernetes components have, comparing the desired state and the current state and making changes to make those equal. If you're doing this to a extremely critical production database, for example, or any sort of pipeline that you have, you want to make sure that it's not going to just nuke all your instances or delete all your backups or whatever, pick the worst case scenario that's going to happen. And so you need to test that iteration loop really, really well. And so we've got a number of tools built into the SDK to help you do that. And then even ship those tests over to us in our certification program to test your operator out as well. So we have a verification side of that, and we have this little utility called the operator scorecard. And this is some black box testing that observes your operator on a real cluster and make sure it's doing some best practices. And we're going to make this much more powerful over time. And then these all end up on Operator Hub, and you heard I mention about earlier. This is a community listing of operators that are high quality, kind of fulfill some of the tenets that we talked about here, and get to that phase 1, phase 2 in the maturity model, and ideally much further. First is our Helm SDK, and this is the easiest way to get started, and quote, no code. This is different than Kelsey Hightower's no code GitHub repo. If you've seen that, it's kind of funny. We've actually written all the code for you, which is the beauty of this. So if you have an existing investment in Helm charts and you want to kind of run those in a more secure and better way, you can take those charts and build them into an operator. Now, what that looks like is you have a custom object that your operator is listening for. So in this case, we're going to make a Tomcat operator. And so we're going to auto pick up that Tomcat name, and that's going to be our new object. And what you can do is you have a values.yaml file, if you're familiar with Helm, that goes in, and those are all your tunables for your chart. And so you compare those two, and it templates out with those values, and then boom, out pops all your Kubernetes objects. You basically hook this up to that CR, and so the spec of that object just becomes those values.yaml. And so you have this really nice self-service way to instantiate a Helm chart without running tiller and the security issues that come along with that, as well as have this thing that's actually actively running in the cluster. If you think about how you use Helm today, it's kind of triggered either by a Jenkins job or a human on a laptop is just inputting commands. Here you've actually got this long-running piece of state, which helps you out. So here's what that looks like in detail. It's basically just like we like containers for immutability and we want to have all of our artifacts bundled in. The SDK build process is actually bundling that chart and our code into a container that is the operator. And then you version that, and then in the middle there you'll see this is our Tomcat object. And so we've got two values that we can tune. And so you've got engineering teams that can now self-tune their instances. In dev, you might want to turn things down. In prod, you turn things up. The nice thing about this is if you handed this off to another team to run, say if you had an internal app that was based on a Helm chart, they can use this operator with a specific version, put in the same values, and always get the exact same result. So this is really great for CI pipelines and handing this off to a team to say, hey, here's the latest version of our thing. Go run it. Go test against it. And then because this is an operator and it's using some of the Kubernetes extension mechanisms, it fits right into OC or kubectl. So you can say get Tomcats in all namespaces, and you'll see that we've got our two namespaces, two different versions of our operator running there. And so that's really great. That's kind of the experience that you want. You get this common debugging across the cluster. Our Ansible SDK works much the same as this, but it allows you to get a little bit further across that maturity model. And so once again, you're taking existing investment in the Ansible playbooks that you have, and this is really great for infrastructure teams that might not be traditional software engineers, and they're used to dealing with Ansible in playbooks. You basically map some playbooks to some cluster actions, and then the operator executes those playbooks when it needs to. And then from that on, the build looks the exact same. All that's put into a container. It's versioned. You get the exact same experience. The object and the output actually have not changed. You can produce the exact same operator with both of these SDKs. Now, of course, Ansible has a really rich ecosystem of different playbooks and other integrations. And so this is really great if you want to have an operator that might go out and mess with like hardware load balancers or go create DNS records or anything like that to really stitch your entire user experience together. This is where the Ansible SDK excels, and then it really gets you across that entire maturity spectrum. And last is our Go SDK, and this is kind of the cream of the crop. This is using internally all the same tools that Kubernetes engineers upstream use to build Kubernetes components. So we integrate with some of the tools, and we participate in the special interest groups that make these tools. But you don't have to be an expert in those. We kind of handle it all for you. Like I said, we do all the code scaffolding for you, and you get that testing framework and all those niceties. Here's an example of not using the SDK, but kind of a really stubbed out control loop. As I mentioned, you're the expert in your application, and so when you're building an operator, you need to take in all that and kind of execute it in this control loop. But that's all you need to do. We handle all the scaffolding for you. And so this is a good example of just an initial deployment right there where I want to have at least one Tomcat because I see a new object popped up. Oh, I've got 0 right now. Oh, I know what I need to do. This is an initial deployment of that application. And then constantly, you're checking different parameters of the application to make sure that they're in spec. In this case, we're checking that a size parameter is actually reflected in the replica count. And you would kind of do this for every single thing that you care about, doing upgrades along the way. If you know how to go from version 1.1.1 to 1.1.2, if you need to execute different pieces of logic, you can actually do that in the operator. What's nice about this is you don't have a way to do that in Kubernetes objects in general. If you have a Jenkins pipeline that just outputs 35 YAML objects, there's nothing there saying, oh, start this migration and then shut off this pod and move this data around, or I need to change this config map to have a migration to a different data format. These are all things you can do in an operator, and that's that higher level construct that you don't get inside of just a stateful set or a deployment. And so you can use that entire toolkit to make really, really complex applications. We've been really lucky to see this operator concept take off since we introduced it in 2016. It's proven to be really powerful, and we've kind of been one step ahead of where the Kube community is going, such that these tools are ready for these complex distributed systems when we're now running them. So all of the folks that you saw earlier from the automated vehicle testing and some of the NASA pipelines and Spark and Kafka and things like that all really excel at being run by operators because there are a ton of different components there that need to be done. So here you can see a few of them. A lot more listed on Operator Hub. And what this does is it lowers the barrier to entry for your engineers picking up a piece of software to prototype out a new workflow, for example. Hey, I need a NoSQL data store. I've never used one of those before. Oh, let me go see if there's an operator, pull off Couchbase. It's got all the operational expertise baked in. And so then you can get really quickly up and running. And this is really, really nice. And then you can standardize that across your organization as well. So everybody's using kind of the same set of tools, and so you can debug them, have the same security testing, that type of thing. Here's just a really cool one that kind of shows off this, one of the cooler things you can do with operators, which is Amazon published this Amazon Service Operator. And what this does is abstract away Amazon API calls into Kubernetes resource definitions. So if you want to make a new S3 bucket, you can actually make an S3 bucket object type with kubectl, and then this operator will go make it and make sure it stays in sync on Amazon's side. And so this is a very Kube native way to start interacting with one of these clouds. And so we hope to see more operators pushing the boundaries of things like this over time. So we already talked about this a little bit, but I want to break down exactly what you need to do if you were going to leave this session right now and go make an operator. It's kind of a different way of thinking. As the engineers that were on stage earlier talked about, our Scrum teams had to go through the same process. It's a different way of thinking about how you architect your applications and then how you deploy them. Oh, I think I hid that slide. Shoot. Well, we already talked about the reconciliation loop there is really what you care about. And you need to think about how do I source all of my state from inside of the cluster? There needs to be no external state because then your operator can't see what the desired versus the actual is and make those changes happen. And this is really, really key. And it's hard to do at first because you need to shift your mind. And so this is where our SDK comes in. Into play. We've got a bunch of examples of making some of these operators. So if you've ever used the etcd operator, for example, there's a Go implementation of that and an Ansible implementation of that. And so you can compare and contrast them. As well as a number of the operators on Operator Hub itself are all open source, including a bunch of the operators that make up OpenShift itself. So there's a plethora of kind of existing knowledge here. And this is where the OpenShift Common SIGs come into play as well. We have an operator SIG that likes to get folks up talking about what they've made, problems they've solved, common solutions that everybody can pick up and use. Now, when you're exposing out these operators to different users of your cluster, the important thing is that they are self-service. So we mentioned that we want this cloud-like experience. We want everybody to be able to expand and manage their own database instances and machine learning pipelines. And so this is the experience you get inside of OpenShift. So you can see all the operators that have been installed in your namespace for your use, and then you're interacting with objects that feel very kube native. So here's a MongoDB replica set that's going to get you a production-ready MongoDB, and you don't need to be an expert in how the TLS certificates are generated, how these components discover each other, that type of thing. And at the end of the day, what we're striving for here is simpler GitOps. If you think about, you want to run something through a CI and CD pipeline, and you've got folks reviewing it along the way, you don't want to be changing 35 different Kubernetes objects, and now you're not exactly sure what happens because you're an expert in maybe the front end of this thing, but you need to change, propagate a value all the way through to the back end, and then test all of that. Instead of it being 35 objects, it might just be 2 here. So here we've got a custom front-end object, and this is just a custom operator that you can write inside of your organization. And then pull off and depend on the MongoDB operator for your stateful storage. And now when you're making configuration changes from staging to production, for example, you can imagine a PR review is just a few lines changed instead of all these objects all over the place, and you don't know what's wired to what. And this is really great because you can have different teams inside of your organization that are experts in different areas of your application, especially if your application maybe is 100 different microservices. Is not a crazy example, as we saw with some of the folks that presented earlier. And then, of course, all that ended up eventually into all of your Kubernetes objects, your deployments, your pods, your secrets, et cetera. And then, of course, security is a really important part of this. And so admins need to have full control and visibility into what's going on. So if you log in as an admin persona inside of OpenShift, you can see all the subscriptions to all the operators that you have. As we talked about earlier, this attaches 2 different channels, and you can have either manual or automatic approvals to help you keep these operators up to date. And the general flow is we want to provide our partners a path to update their operators on your clusters so that you get different bug fixes and security. And then those operators know how to do seamless rollouts of your applications. And so that's kind of the way that the pipeline works. And this gets you a little bit better of an experience. You're getting that expertise constantly improved into your database operators, your machine learning operators, et cetera. I want to invite you to try these out. So we've got a Getting Started guide that walks you through using all of the components of the operator framework. I mentioned we have our special interest group. That's the second link here. It meets on the 3rd Friday of every month at 9 a.m. Pacific. So we've got a lot of folks that are coming and talking about their experiences, and we'd love to have you there. We've also got mailing lists and other asynchronous forms of communication. And then operatorhub.io, please check it out. All these operators are really great, and if you have an OpenShift 4 cluster, as you saw earlier, those are all inside of your cluster as well. Since I've got a few minutes, let's take a live look at one of my clusters, and we can just poke around with some of the operators. All right. So first, let's take a look at operator hub inside of the cluster. You saw a little bit of this earlier. If my internet connection is decent. And so here you can see that there's a bunch of different services here. And the nice thing about this is this catalog gets added to every single day. These partners are in charge of their listings, and so they're constantly revving them as new versions come out. They have new capabilities. And the power behind this is if you're thinking like, oh, why don't I just run this? Why do I need something to manage the lifecycle of this? Is every time that you install one of these, you're actually wiring up service accounts that have the exact minimal set of permissions that you need to run this. So if an operator doesn't need to create secrets, then it doesn't need to have access to any of your secrets, for example, inside of that namespace. If you want to isolate an operator into just one namespace or all namespaces, you also have the flexibility to do that. So it's really, really powerful. Here's the admin side of it. So on this cluster, you can see that I've got AMQ, CockroachDB, code-ready workspaces, a few others installed on here. Actually, let's talk about this metering one for a second. This was mentioned in one of the talks. And what's great about this is actually a cluster extension powered by an operator. So we're teasing apart some of the components of OpenShift. So like the logging stack, for example, is now kind of optional. If you want to install it, then you can use an operator. It all gets set up and wired up for you. Same with metering, same with some of the other projects we have, like the descheduler. And this is so that you have full control over the experience of your cluster. So if you want a slimmer install by default, that's what you get out of the box. And then you can kind of add on all these other components, which is really exciting. And all that happens through Operator Hub. So let's take our admin hat off for a second and go over to our developer hat. And so we're going to jump over to our installed operators. And I have a sample production API backend project that has just a few of these objects and operators installed in it. And so here you can see I've got self-service access to make a CockroachDB, for example. You can explore some of the capabilities of it. And then you've got these templates that have all the defaults inside of it sourced from that developer. This one is really a good example of how complex these things can be, and not necessarily in a bad way. It means that you have the tunables if you need them, but they're all smart defaults managed by the operator if you don't. So if you wanted to bump up some of the cache sizes or something like that, you have self-service access to do that. Even if you wanted to experiment with this, now you have create a new namespace, install the operator, go mess with one of these instances without having to mess up any of your infrastructure. You're not experimenting in development or anything like that. And as you saw earlier, this is all integrated into our new developer catalog. And so this blends together any servers, broker-backed instances you have, operators that are installed, as well as some of the other things that come out of the box, like our image streams and things like that. So here we looked at a Kafka one earlier, and I think it's worth revisiting that just because of how powerful it is. So I think I've got a Kafka running in here. And it's really important to note how many objects this thing is managing. These applications can get extremely complex, and this is generating, if you look at these secrets at the top, there's a CA and a bunch of certificates that are generated, and they're stored as secrets. They get mounted into some of these pods. If you want to rotate these secrets, it's a whole thing. You got to restart different components. The operator does all of this for you. It's really, really powerful to get a production-ready Kafka cluster, in 35 seconds. It's not something that you can typically do on most infrastructure. And so it's really, really powerful. And remember, this runs anywhere. Anywhere you can run OpenShift, anywhere you can run Kubernetes, you can get this operator. So you're not tied into one specific cloud provider. This can be virtualized on your laptop. And so if you want to do local development against an operator, you can do that as well. So I think I'm about out of time. So hopefully that was a good look at the overview of what an operator is, how you can build operators, either take them off the shelf, and if you're a software engineer inside of an organization and you want to ship an operator, we've got a bunch of tools ready for you to do that. Then a live look at some of it in OpenShift 4, which I want to encourage you to test out as well. Thank you all so much.